Hello everyone, this is Jamie here. Welcome to another session of Vista Export Services. In this session, I'll be taking you through the process of using CameraMatch AutoSetup in Blender to automatically camera match your photos with one click of a button. Also, I'll be helping you understand some of its parameters. So without further ado, let's start by opening the CameraMatch tab here. This first toggle here allows users to click and locate the Python Vanishing Point Detector file by clicking on this button and loading it here. It's worth noting that both the Vanishing Point Detector and the CameraMatch script need to be in the same Blender folder. Here is the exact folder path where I have mine. You have the C drive, the username, app data, roaming, Blender Foundation, Blender, 5.1, scripts and add-ons. Do check the PDF manual for further information. Once the VP detector file is loaded, go to the background photo section and click to browse for image and pick this image here. Further down the panel, we have the auto detect VP and apply to camera button that will automatically create the camera, create its target, create the horizon line, create the VP verified cube, create the image with the vanishing points, insert it in a camera background and automatically adjust the render size output. Let's click the button generate everything. As you can see here, everything was created automatically with one click of a button. The following step is to select and move the camera target vertically so the camera horizon line can align with the yellow horizon line seen on the VP background image. As mentioned earlier, here is the VP verified cube automatically created to help align the camera. Let's select the camera target first and begin moving it down vertically under the Z axis. The yellow horizon line on the background image is where the true horizon line is according to the script location. While the camera target is still selected, let's move it further down to align with the yellow horizon line. Now the camera is matched properly. Job done. The next step is to begin creating objects in a scene using the VP verified cube to help find the true scale of the scene. Let's begin moving the selected VP verified cube object to the left. As you can see, the verticals of the VP verified cube object are not straight like the background photo. That's because the photographer used the vertical tilt correction tool to correct the converging vertical lines. 3D applications such as 3ds Max and others can recreate this vertical tilt correction effect. However, Blender can't. There's more detailed information regarding this problem in a PDF manual link. Blender users can alternatively apply the vertical tilt correction as a post-process in Blender's compositor or export the camera to other applications via the camera transplant or via FBX. Either that or simply avoid photos where the vertical tilt correction was applied. Let's begin changing the dimensions of the VP verified cube object to fit the facade of the retail. Next, let's right click and choose to duplicate VP verified cube object. With a new VP verified cube object created, let's adjust its dimensions and position it accordingly to fit the bus stop dimensions. The following step is to determine the real scale of the bus stop. Currently, 3D scene looks too large. Because the bus stop seems to be about 5.7 meters in height, let's move the new VP verified cube down a bit to be better aligned with the background image. Next, let's open the Google page, bring in the background photo and take a screenshot of the bus stop with a bit of a context around it. Click on the Google AI button and Ctrl V to paste the screenshot. Let's ask Google AI the height of the bus stop in the Marble Arch, London. We're doing this in Google AI because it has a large database of bus stop dimensions around the world and most objects really. Having said that, not every single Google AI information is 100% accurate. The best course of action should have been to personally take the measurements beforehand or send someone there to be more precise. According to Google AI, bus stop height is 2.5 meters. Back in Blender, let's open the CameraMatch AutoSetup tab, scroll down to this section, Scene Scale Calculator. In the real world height values, let's enter 2.5 meters as suggested by Google AI. Next, let's select our bus stop VP verified cube object and click on a button to read height from selected object. As you can see, it automatically picked up the VP verified cube object height, which is 5.7 meters. Now let's click this button to calculate and apply it to scene scale. Now the entire scene has the correct scale with one simple click. Double check the new scene dimensions. While the VP verified cube is still selected, go to the item tab. As you can see, its height is now 2.5 meters. While we are at it, let's also select and check the height of this retail unit here, which is around 8.82 meters. Let's save the scene now. The next step is to click on this button to export camera data for Transplant. Name and save the file. The camera components, the two VP verified cube objects, the image background and the scene settings will automatically save as a JSON file. Let's save the file again, close the program entirely and relaunch Blender. With a new Blender relaunch, let's click the button to import camera data for Transplant. Choose to open the previously saved JSON file and voila! The camera components, the two VP verified Q objects, the image background and the scene settings were automatically brought in a brand new Blender scene. If we go to scene units, we can clearly see the unit system scale is unchanged. Also, while the VP verified Q object is selected, we can see everything is still to scale. Now we can save and continue working on this new scene. As you can see, it was quite a quick and easy process to camera match. The next step is to try a very challenging camera shot of a car. Let's start with the new Blender scene. As you can see, the VP Detector Python file is already loaded in a camera match dialog because the system remembers. However, let's click to load it again. Next, let's click on the button to browse for image and choose this car photo shot here. Let's click to auto detect VP and apply to camera, and voila! As you can see, the photo was automatically camera matched with one click. One can actually see the camera horizon line aligning with the background image horizon line. The following step is to change the VP verified cube object dimensions and move it accordingly to fit the car seen in the background photo. The next step is to find out the real height of the car seen in the background photo. Let's increase the VP verified cube object dimension height a bit more and move it accordingly to better align with the car. The car in the photo is a Honda ZR-V, and here are its real dimensions. As you can see, its height is 1.622 meters. Again, in the scene scale calculator, let's set the real world height, which is 1.620 meters, and click on the button to read height from selected object. As you can see here, it's 7.7 meters. Let's open the unit system scale first and click on the button to calculate and apply to scene scale. While the VP verified cube object is still selected, let's check its height dimensions here. As you can see, its height is now 1.620 meters, which is also reflected on these dimensions here. Now we can enter the remaining dimensions seen here, such as the width and length of the car. Since these dimensions are now correct, now it's simply a matter of placing the VP verified cube object accordingly in the scene. Let's use the object's transform location and position it accurately in the scene. Let's save the scene now. Next, let's click to export camera data to Transplant and save it. Let's close and exit Blender, relaunch the program again, and click the button to import camera data from Transplant. Choose to open the JSON file previously saved, and there you have it, done. To check if all dimensions are okay, let's click on the VP verified cube and check its dimensions here. As you can see, its height is still 1.620 meters, the width 1.840 meters, and the length 4.570 meters as seen here. The final step is to save the scene, bring in your 3D assets, and set up your Blender scene for the final render. These are some of the render results with a bit of post-production work. I really hope you found this video useful, and I hope to see you on my next one.